Hey guys, how's everything going today? Let's take a look at number 87 of LeetCode, Scramble string. It's labeled as hard. We're given a string S. We may represent it as a binary tree by partitioning it into two non-empty substrings recursively. Wow, the description is very long. So we're given it a grade. So we can separate it into the binary tree as GREAT. So now we may choose any non-leaf node. Wow, it's very hard to me to pronounce it. Non-leaf node, and swap its two children. So rotate it, right? Okay. If we choose the node GR and swap its two children, it produces a scramble string RGEAT, which means this GR rotated and RGEAT. Okay. We say RGEAT is a scramble string of grade. Okay, by one swap. Similarly, if we continue to swap the children of nodes EAT and AT, which means at the node here, E, and AT, and it produced a scramble string RGTAE. Okay, we say that RGTAE is a scramble string, so we can swap it for any times we want, right? Just keep rotating it forever. And what we are going to do is that given two strings, we need to determine if S2 is a scramble string of S1. Wow, I have to say, I must be honest. I tried to solve it with 30 minutes or 1 hour, but I haven't. I couldn't think of a clue of how to solve it. So I searched on the internet and find some materials and read it, and it turns out that the basic approach is pretty simple. So I do some explanation. So hope you don't mind. This is not from my head. Okay, so let's say if we're given a grade, the example input is like grade and R regeat. I don't know this even it is a word or not. I think not. The one true key point of this problem is that if you mean for the binary tree, there is only one root of a binary tree. That means, what does it mean? It means, let's say, if the binary tree, which transform gray to regeat, if it separates at G, okay, G, R-E-A-T, so no matter how you swap it, the G will be at the beginning, right? No matter what you do, G will be at the beginning or at the end, right? Yeah, so you swap you can swap anytime at the read as you want, but it doesn't change the position of G. So is G must be the head? Yeah, it's not. And or it's at the end. It's not. So the binary tree cannot be rooted at this position, right? So it must be here, here, or here. So this gives us the problem that gives us the idea that we could do it recursively. Like for G, we only compare R and we only compare T. No, it doesn't match it doesn't match anyway. So we need to check if GR matches RG or AT, right? By match, I mean it is scrambled. It could be matched by scrambling them. So this is a possible recursion solution. Okay, so the idea is clear now. We just loop through all the possible root position, which is how many spaces between these letters. So it would be length minus 1. Okay, and we just compare them one by one, and then we can do it recursively to find the result. We just through if. Okay, for this is a scramble. If S1 length is not equal to S2 length, yeah, it clearly doesn't match, right? It returns false. And the other one is now for let I equals 0, I smaller than. So the possible points of the root node is like this, right? We for each possible node, which is I, we now just essay the left part. Okay, left part would be S1 slice I plus 1. Yes, for 0 we would get the first letter. Okay, const right equals S1 slice S plus 1, right? Yeah. But because there might be a swapping occurring at this position, when we are comparing, there will be two possibilities for S2. The first possibility is that let's left. How should I say this? Okay. Okay, I just name it left 2 1. Wow, this bad naming. A. Okay. Oh, I'll just say left 2 1 equals S2 slice. This is the same. Left 2 slice. This is the same. And another possibility is that comparing G with this T, right? So it's from rear, not from the head. You have to. Okay, my bad. Here is right. It's left to 2. S2 slice. Okay, the position would be the ending element of the S2 would be S2.length, right? Minus 1. So for I equals 0, it will be itself. So this is the same. Const left to right 2. Okay, right 2 would be 0 to this, right? Let me check. Last element. Yeah, 0. Yeah. Okay, so now we can do, if some of them matches, then we can return true, right? If not, we return false. Return false. If there are two possibilities, is scramble left with left 2 minus 1, and is scramble right 2 1. Right? If this is true, it means the condition is matched. And is scramble left. This is another possibility. By crossing, compare them. By how to say cross? Yeah, you know what I mean. In a reversed way. Is scramble. I mean, you know what I mean, but it doesn't mean the interviewer knows what I mean. So I'm sad about my English. But God. So okay, so if these two possibilities are all checked and the sum of them is matched, is okay, then we return true, right? And what the ending condition for the last element? I say if there was one letter, we just do what we do is compare S1 if S1 equals S2. Well, I think we have finished the algorithm. Let's try. Oh yeah, we accepted for this short, only 5 letters example. Now we just submit. Of course, TLE, the solution is right, but it takes too much time. So what's the time complexity? Okay, for here, this is O, obviously it's ON. And here, it's what is this? Wow, I don't know what this is. It's like binary tree. So this will be. Let me check. So for n letters, for here there will be one check, and then check the rest. Wow, so the time, I say Tn would be Tn would be T1. T1 will be just the 1, okay? So it will be T1. T1 compare this, and then compare that, right? Plus Tn minus 1. And then plus T2 plus T. This will be all times 2, so I'll ignore it. Tn minus 2. Right? So it finally will be Tn minus 1 plus T1. Well, what should this be? Wow, it's I don't know. Well, it's big. What is this? Okay. Let's try. It should be. This one is 1 to n minus 1. This one is minus 1 to 1. So it's still n. Oh, so it's the sum of all the numbers, right? Okay, so t plus t1. It would be in t n 2. Oh, I find something. So it's two like this. It's before this originally is this like 2 times this, right? And then sum them up. It's 2 times this. 4. So it's 4. And now what is it? So it's square. it's four times. Oh, anyway. And we can reduce another one of this. It would be 2 times 2 t would be, oh my god, so it's 2 times t n minus 1 plus some plus t1, and then plus it again, right? So it would be 4 times 4 plus 1, right? Plus 1. And times t n something. Well, forgive my nasty mathematics. It should be okay. So it's obviously now it should be like 4 the pole to the pole of n, right? So it's like, oh, something like this. Wow, it's very, very slow. It's exponential. Exponential, right? Exponential. Yeah. Okay, so this is actually not good. So how can we improve it? So every recursion, I think it could be improved into dynamic programming or using some memoization. Let's try to solve it by memoization. We see that for each compare, like a G, we compare GR and GT, right? It doesn't match, and we go to GR again. We will compare RG again. But when we compare GR and these two RG, we will still start with G and R again, right? It's not good. Now, return back to our recursion solution. We're comparing this substring. We're passing down the substring of S1 and S2. So for each S1 and S2, I mean in recursion, we are passing down substring, which is S1 substring slice ij, right? Which means each comparison would be unique as, could be, how to say, marked as a unique key with 4 numbers, ij, kl, right? The start index of the first substring and the start of the second substring, the ending 1 and 2. But with the condition that the distance between ij and distance between k and l are the same. So we can reduce them into 3, right? 3. Reduce to I, j, and nth, right? Which means start at g here, r here, with length of 1, it would mean gr. If it is 2, means gr and rg. And length would be 1 from 1 to s1.length, right? Which is n. I'll say n. Wow, this is clear. It's just made it clear to us that we can just calculate this, how to say, 3-dimensional array, right? Because we have 3 factors here. Okay, let's start with first we copy the here and try to rewrite it. is this dynamic programming? I would say nah. It's kind of like a memorization. I'm not going to find some optimal solution here. I'm going to determine if something is right or wrong. So I don't think it's that dynamic programming, but just to use a three-dimensional array to keep track of the intermediate result. I would say this is what memoization. Memoization. Okay, so the three elements of this key would be I, j, and nth. Nth would be 1 to n. I would be 0 to n minus 1. So the nth will be the same. It's like a cube, right? So we say cache. I just use cache. It doesn't matter. Okay, array n, and I fill it. So I will fill. Oh, should I fill? If I fill, it will be the same. So, oh, sorry, I fill 0, and then map. So for each so it's because it's a cube, and now we will return a two-dimensional array, right? So it's still n and fill 0, and then map. Wow, this is hard. And now we can finally we can have another array. Yeah, we have a 3 array. Fill 0 map. Oh, my bad. So we fill 0. It's okay. We don't need to map. 0 means true or false, right? So yeah, we can use false. Should we use true? Here we'll default to false, so we'll find everything right. We set it true. So default. Yeah, it's false, I think. It doesn't matter. Yeah. And now we can update this cache. Okay, so we can we'll comment it out. This check could be done at first. It's this is needed, and then okay. Now we let I just traverse through all the elements, right? Yeah, with this ij stuff. I smaller than, okay, I'll say n equals s1.length plus let j smaller than n j plus. This is an ij, and now length, it will be let l 0, no, it should be 1, l smaller than equal to n, l plus. So this is for each element in the cube. Now we need to do some calculation. Yeah, if L equals 1, if it's only one letter that's this to be compared, then we have this one, right? We have this. If it's the same, we return true. If not, we can set them to false. So the cache I, j, l would be s1 I equal to s2 j. Yeah, And if not, okay, so if it's 2, according to our algorithm here, like for GR, let's check. Let's say GR, when we're comparing GR, this is not true. This is not true. And GR and RG, we first compare GR and GG. Oh, my bad. I should start with the length first for this comparison. Yeah. Because we should compare 1, 1 first and then 2, 2 first. That's why we use cache to save the time. So here, okay, I'll move the back here. Yeah. And still, it should be like this. Oops. Now, when we are comparing GR and RG, we cannot just search through all the possibilities like G, R, and RG, right? So it will be the same. We need to use another for loop to check. Okay, but now there will be for, wow, this is huge. For that, K will be 0. So the problem would be the ij with length 1. So K from 0, and then the K would be, oh no, K would be 1. K would be smaller than L, yeah. K plus plus. We're going to start from 1 and then compare 2 and 2 deduct the result of comparing these 3, right? Yeah, so the result would be I, J, L will be, for each K length, it must be compared to, it must match this and the rest, right? So, just as what we did here, like this, there are 2 possibilities. So for this one, which means comparing I and SI, the first substring starting at I with the length of L, comparing to the substring of S2 starting at J with the length of L, it must be first for the first element if they match, right? Okay, it would be, wow, this is hard. Maybe I should just still write it into a simple form. Okay. Okay, so start 1 K is length. So start 1 will be, I would say, Start 1 would be I. Yeah, const start 2 equals j. Start 1 1. Okay, this is one possibility. Start 2 1. Const start 2 1 1 2. The second possibility for I would be wait a minute. So oh yeah, I need to use the left and right thing. Yeah. Left. Compare it first and then compare it. Left 1 would be I. Left 2 would be I. Const left 1 2 would be K. Yeah. Right. It's right. So it should be L minus. Wait a minute. It's 3 1 2 3. In length is 3. Then there should be K is 1. We start 1. Okay, so it should be, oh yeah, it should be L minus K. Right? Wow, I'm a little confused here. It should be start. Oh, if it's 1, then it should be start with 1. Oh, it's K. Const left 2 equals K. Because we're comparing the I means the start of the first string, the J means the start of the extra string, the L means the maximum, the K means the where to compare. This will be, yeah, so it's sure the right would be I plus K, I plus J plus K. Okay, first we compare IJ, or we compare J I plus K, or J plus K. Yeah. Okay, now we're going to be fine. If cache, okay, we first compare left one, and right left 2. Okay, the first one is left 1, left 2. With this possibility, and of course compare these two. Right? Yeah. Okay, compare. So the cache would be left 1, left 2. Yeah, this. The length would be K. If this is true, and wow. So this should be 1, 2, 2, these two, or cross them. Here's 2, and left 1, left 1, 2, 2, left 2, 1. Yeah, if these are the same. Yeah, if they are scramble string. Wow, it's not same thing. Okay. Oh, the parenthesis problem. Ooh. Okay, if if some of them match, I can break, right? So the result should be that result would be false. If we find any of the matches, we say result is true, and break. We break the for loop, and then we set. Oh, it should be here. Result here. We break, and then finally we set the result. Yay! Like results. Okay, and like this. Here is the for loop. We remove this part, and finally return cache and -1 and -1 and I hope it pass. God knows. Of course not. Missing argument list. Ooh, shit. Still, let L equals 1, L smaller than N, L plus plus. Oh, 4. Shit. N is not defined. Ooh. God. I will never pass the interviews. Cannot get property 1 of undefined. Okay, I'll say log a check IJK. Check 0, 0, 0, 1, okay, 0, 1, 1, 0, 2, 1, 0, 3, 1, 0, 4, 1, and then it will be going to check 2. Oh, maybe here. Set IJL. IJL. Okay. So 0, 0, 1. Okay, for 1, it's all done, and now we check 2. So 0, 0, 2, 1, it means 0, 0, 2, 1. Okay, checking GR. 0, 1, 2, 0, 4, 0, 0, 4. Checking, and then there comes this error. Ah, there's boundary problem, right? I mean, I0 1, k is 1, k is 1, so left one would be 0. Problem comes here. 0, 4. There is 0, 4. 0, 4. We said it. Depth 2 here. Wow. Pinch. Mm. 0, 4, 2, 1. 0, 4, 2. Okay, 1. Which means I put the example down here. Which means 0 is G, 4 is T. We already checked that. Wait. The when we get 2, right? We're going to check. No. Check. Oh, the I is the same. We're checking I. So we set console knock set IJL to result. So we set 002, which means GRRG false, and then GRRG okay is 012, which means 0 GRGE not okay. So and then finally we get 03 GRAT not okay. Okay. There's an overflow problem, right? Yeah. So the L would not be for here. We should not set J to I to N because there will not be that long. So I mean, if length is I, it would be N, right? So for 2, it will minus N 1. So minus L plus 1. So here would be minus L plus 1. Should this work? Okay, there's no error, but we got the wrong answer. Wow, 005. We should, my bad. Because we're comparing the whole string, we should set return 0, 0. Oh yeah, we're accepted. Sorry guys, I made a mistake as the boundary of the boundary here. I should pay more attention. Yeah, because this is the length of the word. So for the start, there would not be that many options. We need to narrow it down. My bad. I hope that the interviewers who could ignore this part, but it's really hard. Algorithms. I'm not to make this clear. I'm not as good at algorithms. I just make these videos to make myself improve myself and hope it may help others. Sometimes I find that just that the beautiful solutions written on the internet is just not that good for me. I cannot understand. I cannot get why they could think of that solution. So anyway, let's submit. Hope it will get accepted in a real check. Oh, wrong answer. Wow. Wrong answer? That is bad. That is bad. Let's log it. So console log cache. I will so speak console log 0. B should be start 0. Yeah. This should be good enough. So so the length of 1. I made a mistake. When we set the it is good. So the first one is false. It's okay. This one, false. First false. AB, BB, false, and ABB, BBA, false. Wow, we have to debug. Sorry guys, log here. So log set IJL cache IJL. Its first one is okay. 0, 0, 1 false true. 0, 0, 1, 1 false. Yeah. 2, 0, 2 1 true. 1, 0 true. 2, 1, 1 true. 1, 2 false. 2, 1 for 1. I think they're right. And now for 2, 0, 0, 2 false. 0, 1, 2 0, 1, 2 is true. Yeah. And 1, 0, 1, 0 true. And 1, 2, 1, 2 false. And 3 for 2 there is only this, yes, right? And for 3 just false. Why? For 3 we need to check the K. I would say log the K if L equals 3, log check for K. Left 1, left 2. Left 1, 2, and 2. 2, 1. Left 2, 2, 2. Let's run. Okay, check for 1, and now we start at 0, 0, 1. Yeah, so here 0, 0, 1. Okay, 1, 0, 0, 1. Sure. Shit. I know what happens. So so for this one, it should be K. Yeah, and this is not K, man. It should be L minus K. And here, there's 1, they have 2, this should be K. But this should be L minus K. Ah, shit. Still wrong answer. Wait a minute. Wait. There's for K, 0, 0, left 1, 2. Okay, case 1, so left 1, 2, 1 would be 0, 0, 0, 0, yeah, so 1, 0, 0, 1. And 1, 1, 1, 1, 2. 1, 1, 1, 1, 2 is false. So it's false. And now there's this case of for K here is 0, 0, 1, 0, 1, because 1, right? 0, 1. Yeah, so 2. Yeah, this is right. And now 0, yeah, 1. Yeah, 0, 1. It's right. Okay, 0. Why 1? It should be 2. Because AA, right? Should be A plus When we're comparing these three, we should say A, B, B, or A, and this one. So A, 0, 1, or I'm a little confused here. I, 0. I plus K is yes. Left 1, 2. Compare 2, 2. Yeah, the coordinates are right. 0, 1, 0, 1, 0, 1. Okay, so check for K, 2, 0. Check for 2. Oh, check 1. Maybe my brain just is gonna explode. 1. Can somebody help me out? For k1, it said false, but actually cache 0, 1. This should be not 1. This should be 2. Here. Should be 1. The index is wrong, right? I mean, when we're check 3, index 3. It's here, ABBA 0101. It means 0, 0, 0. This is right. This one is right, but this one seems to be wrong. This one should be this and this. We don't have this index, right? This one is I, this one is J. This one is wrong. Oh God. Yeah. This actually doesn't have the enough information. I mean, I should change to this one. This is for sure. I say const first equals I just use this one. This one might be easier. Cache the first one I, okay, and then the next one is J, K, yeah, and cache I plus K, J plus K, and L plus K, L minus K. Oh, this is right. And then we should say I and this one. What is this? It should be I'll say it should be J plus L minus K. Is it right? This is J, right? This is nth, so it should be minus plus L. 3, 1, 2, 3, minus 1. And then index should be the length K. K because K is 1. So it should be this. Plus K plus 1, right? This is the index. So you get things index, yeah. And then it should be K. Oh, yeah. And cache AI plus K. And then we have J. Should be this. Oh, we removed the lock. Oh, my bad. Wow, it's really, it's not, it's just it's hard to make it clear about the index. I'm always bad at index, the boundary. Anyway, let's try to submit. Yay! Finally we're accepted, and let's try to calculate the complexity. Okay, here it's and here is already an cubic. This is n, 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 and this is another n. So this is O and 4, and this is also the time and space, right? Time and space. So we cast n to the power 4 of time and the cubic space. Yeah, that's all for this video. So I'm sorry, I'm not that good at algorithms. I hope you learned something from my mistakes, just to care about the boundaries. Yeah, just pay more attention, and hope it helps. See you next time. Hope you stay home and stay healthy. Bye bye.